Hello everyone and welcome to our discussion on Module 5 in data science languages, and this will be talking about advanced data structures. So continuing the conversation around useful things like pandas and so on. Module 5 is what we'll be talking about today, followed by some discussion of the reading, then Python, R, then we'll move on to deliverable 5 where we take a good close look at that. So again, Module 5, dealing with advanced data structures. So in Python we have things like classes and objects. We'll talk a bit about those. R, typically you deal more with objects. And then we'll talk about deliverable 5, which is centered on the application of advanced data structures to a problem. And you're going to, in Python, create a data frame that contains a separate column from a single data frame. So you're going to do this whole split up stuff. And then you're going to create a file that you're going to then read with R. R is going to read in that file and then do some pretty pictures, right? You're going to do some plotting with ggplot, and then lattice, and then you're going to do some typical statistic stuff, stats along the way, standard deviation, means, and so on. Maybe go crazy with a little correlation in there too, right? Reading for this topic centers in the Python books, chapters 4 and 5, which deals with NumPy, around arrays, vectors, and computation, and then pandas. And the reason those two things are really important, almost every example you see of data science work is using NumPy and pandas. Almost every single example, every single project you work on, most likely you'll be using them. If you're not using them, you're going to be using something very similar to them. Perhaps things like Spark data frames and some ML libraries. But to start with, it is the most common used set of libraries in certainly Python. That's why it's essential that you master them, and that's why we spend a lot of time talking about them. And then in R, in the R book, step-by-step guide, function guide to data analysis, chapters 8, 9, and 10, we'll talk a little bit about them in a moment as well. First, we'll talk a little bit about Python. So Python's one of the important concepts to understand is a class. And it's the whole point of a class is that it simplifies essentially the software development process. That's the intent. If it doesn't do that, you're probably not doing it quite right. So the idea is that you do a certain amount of combining together of those things which naturally fit together. An example here that you're seeing on the screen is that of a circle. A circle has a characteristic, which is its radius. So, and then also potentially things that are actions that can be done upon it, such as things like calculating area. So you've got a combination here of code, which is things like get and set radius and then get area, with data, which is the actual radius itself, which is being persisted inside of that instance of the class object. Whenever you're creating these things, you generally do the self is the keyword that you use a lot, and then it's essentially kind of analogous in some ways to this in some programming languages like C#, C++, and so on. And there's also something that's very similar to a constructor, which is the underscore underscore init underscore underscore. That function is something that is invoked at the instantiation. It gets called. So let's take a moment and see if we can go poke around in some code, right? So rather than a piece a time, a line at a line. And I just spent some time, not too long ago, over the weekend I believe, doing some refactoring of some code that I had written. I have an experiment I've been running around doing some work with text analytics. And it's gotten complex enough that I need to start making it maintainable. So the idea is that I take a collection of files that are generated by students, not necessarily for this organization, but for another one that maybe there are some students that are academically challenged. Or academically integrity challenged. And I want to do some calculations of metrics to see if I can determine similarities between documents, because I suspect that there is some outsourcing going on of the writing, because there's too many similarities in some cases. But anyway, the point of all that is that I've abstracted out classes that know how to do things like open up a Word document and extract from it, from Python, extract from it the text that I care about, and potentially doing some cleansing and anonymizing of that text as well, so that I don't have to worry as much about the student's information being part of the analytics as much as their actual work. The point of all that is that it is a way of reducing the overhead associated with managing and dealing with code. It makes it to where you can reuse things without having to worry about all of the nitty gritty. And it's a cleaner way than doing things like including scripts and so on. And in fact, the best practice is to include via essentially a run command inside of a notebook, the actual a Python library, be it a Python file or a Jupyter file, a Jupyter Notebook file. You run it, and that doesn't actually do anything as far as creation of anything, but it does do things like set up the objects so that you can create them. So it would do something equivalent to running. You would have this class circle in a separate file, and then you would run that notebook to instantiate, or to enable you to instantiate that circle. So whenever I run it, nothing really happens. Didn't take very long, because all it did was basically say, okay, you're going to make this thing called a circle. It's going to have essentially a constructor that has a default value of 1 for the one parameter outside of its own instance, and everything that is part of the class, generally speaking, has to have self as the first parameter, because it's a way of referencing itself. A little hackish, but it kind of makes some sense. Also, if you want to access a property that exists on that instance of that class, you have to use the word self everywhere as well. So you do self.something in order to get or set the values associated with that instance of that object. And also returning things and doing calculations based upon it. All those have to have this self.radius. If you just have radius in here, it's probably going to yell at you saying, I don't know what that is, because there's not a radius that exists. So once we've created the template, if you will, and it's similar to creating a function, right? So we do def func and we define some function, but nothing really happens until you call the function. Same sort of concept. So when we actually here created an instance of circle, and we get some values from it. So I didn't give it anything, so the default radius is 1, and the default area, based upon our lovely pi r squared calculation, is 3.14. It looks a lot like pi, right? So it's because it is. Constructing a separate circle with the value of 42 for the radius produces a different result. And these are two different objects. If you do C1 versus C2, they're very different things, right? And you probably, this is when it always gets interesting, can take a look at those values. So there's what C1's radius is, and C2's should be quite different. So it's an instance of an object that we're accessing the properties of that instance from code. So that's the whole point of classes. So jumping back, and one of the biggest challenges you may face as you're moving to writing classes is to remember to put self everywhere, right? You got to have self anywhere that you're dealing with something that is a member of that class. That's probably the biggest challenge. So next we'll talk about the combination of data. Some of the stuff in Module 4 wasn't all that great because it didn't necessarily join off of date. Whenever you join things together, didn't necessarily consider date. That's what we addressed with Module 5. And it's basically by doing a merge on, right? So the next cell there that hasn't been executed is going to be merge on. And then you've got a data frame. And I talked a bit about this last week when we talked about how to do merging of data frames and how indexes work and how on works, right? And we could actually simplify that somewhat if we were to make them both be the index. So if for all of your data frames, date is the index, it probably gets a bit easier. But that's entirely up to you. So let's start taking a little bit of time and take a look at the code examples here. So back to our window. Go ahead and close that, and then take a look at the example. And this is coming straight out of your, this particular example comes straight out of your course room materials. I just turned it into a Jupyter Notebook so I could step through it and talk about it. This first bit as I've explained in the past, takes care of mapping between the various computers I use. So it figures out kind of if a folder exists or not. That lets it know kind of where things are. And the primary point of that is to find a root directory, so then I can do relative locations, because I have OneDrive on my various machines that synchronizes everything, but they don't all have the same home directory because of different users and different logins. I probably could fix that by having the same login everywhere, but it didn't occur to me, and I didn't think through the implications. Something to consider for future activities. So here, I did add a little bit of code to check to see if the path actually exists that I'm looking for, and it does indeed in this case. Our import pandas as PD, probably the most common piece of common code across everything you'll ever see. And then I combined together the path that I figured out in the first cell up there with where I know the data is. So there is a GAFA stock prices CSV inside of the data directory. And all I'm doing here is setting up some variables so that I know. If I was being really defensive, and hint, hint, something you might want to do in your submissions, I would probably check to see to make sure that file actually exists. And that's really pretty easy to do. All I would do is if os.path.exists, really kind of straightforward, then I do something. So print something, right? But probably what you really care about is if it doesn't exist, right? And then you say file does not exist, and maybe be nice and say what the file is, right? So it didn't print anything out, so that means it does indeed exist. Next step is to do the read. So we're actually reading the CSV and calculating the average based upon the data frames open plus close divided by 2. Very simple average. The next thing is to calculate a couple flags. And a flag is simply a way of being able to partition it. So we set up what turns out to be basically some vectors here. So let's take a look at one, right? So here's what flag looks like. And it's simply the index and a true or a false, right? So then we take that, and whenever we're doing this, we're basically partitioning and saying the ones that are true is the ones that I want. So this becomes the Google data frame. And then this becomes the...
And then what?
Facebook data frame. Google heard her name, so I had to say something. So here's the second one. And again, we're basically partitioning these two, the one data frame into 2 separate frames so that we can then join them back together based upon whatever we say the on column is. So we're saying based upon the date column of data frame 1 and data frame 2, merge these together. And alternatively, you could do some setting of some indexes and do a join instead. Very similar outcome. Either one would be perfectly valid. And then the last step, and this is important for the work you'll be doing in your follow-on part, is to write this out to a text file, because you're going to need to read it from R later on. So at that point, I actually created that file. So that's the key pieces here in the first bit. You could also potentially make this a bit fancier, and that's kind of where I'm going with the next sort of part of this is that's what I just did. So you may find yourself wanting to simplify your code. And so it could be a good idea to create what I called a slice. There's probably a better word for it. Maybe create a partitioned data frame. Well, pick your terminology. But what this is doing is, again, I find myself anytime I find myself when I'm writing a program that I do the same thing over and over again, I get lazy. And actually, that's a good thing, because what I do whenever I start finding myself repeating myself, rather than copy, paste, and change, which is not a great thing, instead, I pull out and I do a little bit of abstraction, and I pull out the common things and create a function. And in this case, I created this function that takes in a stock symbol, a friendly name, and an input data frame, and returns back a data frame with some basically some reset indexes. And so what that allows me to do then is I can take my the data frame that I loaded up, the same one that we've been talking about, this basically the stock prices for Google, Apple, Facebook, and Amazon, and split them together in a single line of code, right? So this is basically creating a new data frame for Google. This is one for Facebook. This is Apple, and this is Amazon. Given that, then I can start merging them together. So I can do a merge this way. Another interesting thing to think about, if you were to use the set index to the date column and then do a join, you potentially could do it all on one line. So it could be a lot simpler than this. Granted, you could kind of do the same thing here, but it would, well, maybe not. You could do it that other way, but you probably can't do it here. So another thing to consider for this particular assignment, and it's kind of similar to some of the others, is you can only join two things together at a time. You merge two things and it produces a third. Same thing is true if you do a join. You're technically taking a data frame, you're joining another data frame to it and producing a third. To do 4 different data frames together, say 4 different stock prices, you basically do 1 and 2. So you do Facebook and Google, and then you take the result of that and you then add, say, Apple to that one. So you take the result of the first 2, combine it with the third thing that you're wanting to combine, take the result of that and combine it to the 4th data frame, and you've got them all 4 together, which is kind of the whole point of this, right, is to merge them together and produce a single view of the data that you're working on. And so that's pretty much what that's about. And that entire time, Google has been listening. All right. Quite interesting. The wake up phrase kept it awake. And so you'll end up seeing something that looks a lot like this when it's all said and done, and yours will be prettier than mine because you're going to do things like set the labels correctly and make it pretty, right? I'm kind of showing the broad strokes, if you will. Mouse has been acting up lately, so anyway, making it hard to navigate. So back to the PowerPoint. So this is just what I just covered briefly, that you may want to find a better way of doing it that is a bit simpler than copy paste and so on. So merge, a very useful sort of thing. It's very similar to an inner join. It takes a left and a right data frame and produces an output. You have choices about the type of merge that you want to do. And that's what for how is the keyword that you're looking at. So how do you do it? Left, right, outer, or cross. Probably aren't going to do cross too often, but you might. Who knows? You may want all the combinations of things in both data frames. And so as I give you the hint there, at the point that you're doing more than 2 data frames, you're going to do them in sequence. You're going to combine things together. You may want to also, at the point that you've done your work, go out and take a look and do some validation to make sure that it looks fairly close given differences in scale and so on. So that's something to consider, is basically doing validation of your results using external data. So now we can go over and talk more about kind of the 2 topics that your reading helps you focus on, which is NumPy and Pandas. So we'll switch over and take a look at NumPy. So why do you care about NumPy? And the short answer is it does a lot of really cool stuff and that you end up using a lot. For example, in a subsequent course that you're going to take, you're going to do something called Markov modeling. Markov modeling, where you basically have state transition diagrams that are probabilistically based. And the idea is that if I go and I order pizza, I'm only going to wait in line for a certain amount of time. My willingness to wait in line decreases, generally speaking, the longer I'm in the line, right? And so what you can do using time series analysis and using NumPy as the thing that makes it all happen is essentially see what those probabilities look like over units of time. And you do that by multiplying matrices together, essentially raising a matrices to the number of time intervals that you care about. So it's taking a matrix and exponentially multiplying it, right? So the same thing of multiplying it times itself twice is the same thing as squaring the matrix. And that's also the same thing in the case of a Markov process of having had 2 units of time expire. Given that information, NumPy is your new best friend because it makes doing matrix multiplication drop dead easy versus you having to remember how to do that, scratch your head for a little while, and then write the code. So there's a lot of cool stuff that it'll do. We'll go over some of them. If it starts dragging on, I may shift ahead a bit. So this is just setting up some stuff. Again, this is coming straight out of the code examples from your text, right? So here we're basically setting up some arrays, getting things ready. And so here we're producing a random matrix, essentially, a 2x3 matrix with random values ranging between various levels. You can also print things out, multiplying each one of them by 10. So this is taking literally every cell and multiplying it times 10. So very simple operation. You can also add it to itself. So we're adding two matrices together and having the result using matrix, essentially matrix math. You can take a look at the shape of an object as well as what are the data types of that object as well. And then you can do the NumPy arrays as well. So a very useful feature that you'll probably find yourself using quite a bit. Another way of constructing an array as well is to basically pass in this case we're doing something that's two-dimensional, and this is kind of relevant to what you might do in subsequent classes as well. Again, we can see the various the data types of a particular array, as well as the the two different arrays. So here we have something that is an integer versus this one is a floating point. The first one was a floating point up here. Excuse me. And then you also got things where you can do essentially a sort or an arrange, right? You can create empty matrices, and that becomes important as well. Setting up things with zeros, be it a vector, a matrix, or whatever it might be, is quite useful because you sometimes want things to be empty until you do something with them. For example, if you're talking about maybe allowed state transitions, initially everything is not allowed, and then you go through and you set the ones that are allowed. And you would do that by making sure that your matrix has zeros in it. The various data types, you can actually kind of coerce things to be of a certain type by saying dtype equals whatever it is that you want it to be. You can do as type, so you can essentially take an integer and basically treat it as though it were a float. You can turn things from being floats into integers. Note that's just trunking, right? Not exactly what you would consider rounding. It's just literally taking the first bit, right? So be cautious of that. You might want that behavior. You might want it to round. So you want to be careful of which one you're looking for. You can do a coercion as type as well. So this one, we're basically creating it initially as a string, and then we're saying, well, I want those strings actually to be floats. So it's parsing them for you and doing it as you would want it to do it. You can also, again, we're doing a range of values, and then essentially coercing it into a certain different type, using, again, the as type. Lots of as type here. And then you can also set essentially the data type as well to U4. So lots of different stuff. Moving on to something a little more interesting, here's where we talk about doing some arithmetic. So this is just dumping out the array or the vector. So you can see, and that's actually a matrix. You can see that it is a two-dimensional matrix with, or 2x3. And then we can do multiplication. That's going to be the same thing as raising it to a power, right? So that's multiplying the matrix times itself. And matrix manipulation and multiplication, you might want to brush up on if it's been a while. If you find yourself needing to do it, you don't necessarily need to do it for this course. You can also do things like divide 1 by a matrix, or take the square root of a matrix. And these are all things that are very useful whenever you really need them. And here we're basically, I believe, taking the determining if something is greater than something else, right? So we're returning back the true falses where it is true. Slicing and dicing, you kind of have seen this probably with pandas, where you've got ranges and you can pick out the pieces that you're interested in. So it's pretty useful. There's a certain amount of overlap between this and some of the things you'll get in pandas. They work together as well. I'm not going to go through all these because they are, as I mentioned, associated with the NumPy basics of your book that's recommended. And if you're interested, go out, Google that name of that book and GitHub, and you'll find the actual code repository for it if you're interested in learning more and looking at the examples. Here I'm going to basically, I don't want to take forever on this, I'm going to speed up a little bit. You'll find yourself oftentimes needing to change the shape of a matrix as well. So that's one of the things that Reshape can do, is can basically take something that is essentially a vector of 15 and turn it into a 3x5, right? So sometimes that's necessary whenever you're maybe reading in a stream of values, like could be from a bitmap. One of the common projects that you'll do later on is around classification of handwritten digits using various approaches. And in that situation, you generally, there's no real two-dimensional sort of constructs that exist, so you find yourself needing to convert to and from some means of serializing those values, so it becomes very relevant. There's also some fast functions that can be done element-wise on the arrays. We'll go ahead and run that. So that's basically taking the square root of an array, of every item in the array, and also the exponential of it as well. So pretty useful. These examples weren't really, even though it was actually a Jupyter Notebook, wasn't terribly well done from a Jupyter Notebook perspective because you can't see the results of it. So given a vector essentially from 1 to 10 or 0 to 9, we can do things like take the square root of it, and with any luck, it's actually taking the square root of the entire vector, it looks like. So anyway, these are handy built-in numbers. Oh yeah, there it is. So that's the square root of 4 is 2, and this would be 9 is 3. So it is taking the square root. A little hard to read in this format, but that's what it's doing. Additional sort of things. One of the key things you may want to take away from this, and it's already becoming kind of clear based upon how much I'm talking, right? It's a non-trivial set of libraries to understand that is incredibly powerful. You're just kind of getting started with it. As you do more with it, you'll find it to be quite useful. And so that's the takeaway. If nothing else, NumPy is good and worth the time of poking around and learning, right? So that's one of the key things. And with that, I'm probably going to go ahead and shift over. Lots of powerful stuff inside of here. Yeah, we'll shift over and talk about pandas. Pandas, again, data frame, right? It's probably between it and NumPy the most commonly used, probably the most common. We set up some stuff so that it'll print it. Pandas, again, similar to NumPy, has the ability to produce series of values. And you can actually take a look at things like what is the indexes, what is the object. And that's where this is in the series. You probably use series some, and that's, but because this is essentially doing just that, creating a series. But you're probably going to be doing the data frame more, because data frames, it's such a pervasive thing that you do. You read and write CSV files, you're going to probably do it with a data frame, because Panda data frames are the easiest way of interacting with data. And we've talked about it before. This first column is the index, and then there's the columns that are associated with it, that are in this case, state, year, and population. And then we've got all the familiar things you've probably been using already. Head. You can again set the column names based upon the data that we've set somewhere up through there, right there. And so you can potentially adjust the name of the columns as well. You can pick various things with them. They've got a data type as well. You can slice the data frame by using an indexer into it. You can also do the same basic thing by doing a dot notation, right? A hint though is that column names can have spaces in them. You don't really want to try to do that with a dot, although there probably is some workaround to do it. There's also various ways of assigning values as well. So you can add a new column just as simply saying basically, hey, everybody gets the same debt. You can sort things or create a range of things from basically up to 6, and that's what we're doing here, from 0 to 6, and we're putting the dot at the end of it saying, hey, that needs to be floating point. Again, you can create series and potentially assign the series to a data frame column, which is what's going on here. So you're passing in something and you're setting which one of the indexes it goes with. So you're able to do essentially sparse processing on the data frame with that. Again, we can set things like this is setting if it's in Ohio, then it's Eastern, otherwise it is false. So it's in the Eastern time zone versus not, or it is an Eastern state or not, and so on. Moving on to indexing, I talked a little bit about this last week. Indexing is a way of making it really simple to do things like join together data frames. I must have skipped over where we created frame 3. There we go. Yeah, skipped over too many cells. There we go. So, and that's again the nature of a interpretive language, right? Because I skipped over something, it didn't exist yet, and I try to access something that's not there yet because I'm going out of order. So essential things that you end up needing to do a fair amount is re-indexing, which is a way of basically changing the index along the way, either by giving it an index or by and selecting which ones you want and adding and removing indexes as well, right? So here we are shifting things around a bit, and so A is still present, but we've added E. E doesn't exist because it's not up in this other data frame that we created beforehand. We've also ordered them in a way based upon the index, right? So it's sort of like sorting it, but that wasn't really what the intent was. The intent here is to show you that when you add something new, it comes in at null. You can also index this sort of way and basically doing a fill, which is a way of using what was the forward fill. If something's missing, set it to the next thing that you get. There's also the concept of axis and removing axis. I'll skip over that a little bit because we are running a little long. So takeaway, pandas is also good and has powerful stuff like indexes that can make your life easy. Let's see here. This one doesn't talk about merge or join. So with that, we'll go ahead and close these two and shift back to the regular programming. R. We do in this course cover both languages because primarily they're the two more commonly used statistical languages out there. Lately, Python is obviously more adopted than R. R is kind of getting a little stale, if you will. So along that line, you can create custom classes in R, but it is a non-trivial thing and not something that you'll want to do just for fun. If for some reason you do want to do it, you can go to this link and learn how. The short answer is not easy, and it squawked at me that doesn't open. Interesting. But if you Google R and classes, and custom classes probably, or user classes. But generally speaking, you're not going to want to do it. If you were a library developer, you might do it. So it is possible, but probably you don't want to. And this is basically showing just some simplistic way of how you might potentially read a CSV and plot out some graphs of 4 different stock prices based upon date. Could be relevant, could be important, right? And that's within RStudio. Similarly, you can plot inside of Jupyter Notebooks. You'll see me typically using Jupyter Notebooks most of the time because one environment is better than 2. And also notice up there that the index on that one is the date, and we get some pretty nice graphs that look pretty similar to what you get inside of RStudio. So that's also relevant as well. And then here we can switch over and do, we'll just talk about packages, I think. Yeah, packages. Packages, kind of cool stuff, right? We've talked a little bit about libraries and so on. In fact, your first couple assignments deal with them. And that's because they are commonly used. You can use the library to essentially ensure that something is required, and it'll potentially, if it's needed, I believe, let you know that you need to install it, or may actually go ahead and install it for you. We can see some box plots here that did for us. That's what this second bit here is doing. And then we're saying essentially make sure that these packages are there. We're basically bringing them into scope with the library command, but using so across iteration. And then if we require something that may not be installed, then it'll say, hey, it may not be installed. You can also see what packages are installed. So in this case, view installed.packages returns back all the packages that are installed in your environment. And you can see there's quite a few here, right? So probably don't want to dig into that too much. You can go do either r.home or .library. You can essentially go to your root or get environment for home. And then take a look at the lib paths as well. And at the very end of that, it's going to tell you where is your home and what is your library paths. You can also do programmatic maintenance of your packages. So what this is doing is going out and installing some packages such as Zoo and XTS, and giving the repos that we suggest to use from a couple of different places, and then also going and getting something, downloading it essentially, and so the null means it's already downloaded, and so we're actually installing it. At the end of that, those packages that show up in this list. And then you can also remove packages programmatically, so you can go out and get rid of a package that you no longer desire, such as Zoo. And while that's running, we'll go ahead and switch back over and talk about deliverable 5, which centers on advanced data structures. So continuing the theme of the overall group assignment or overall individual assignment for this project or for this class, you're going to go out and do some filtering, grouping, and indexing of a data frame. And it's in the area of financial analytics, so you're basically dealing with stock prices. This is the same thing we've been doing, right? And I kind of like that the course designers took a single sort of data file and followed it for a while. It helps you kind of become familiar with it, something that lets you get to where you begin to know the data. So your instructions is to take the GAFA stock prices file, which we've talked quite a bit about already, read it in, and then of the 4 stocks that are associated with it, their various attributes, separate them into separate, essentially, data frames. So a single data frame per each stock, which we kind of talked about, split it based upon the symbol, and then create an output file that can then be read by R. So you're taking a file that is date and stock price, where each one of the columns is a different stock. And then one being the date as well, probably the index. And then using R, you're going to pick up that file and use Lattice or ggplot or both, up to you, and create some plots of the stocks in a side-by-side fashion. So you want to also calculate mean standard deviation of each stock between Amazon, Facebook, and Apple. And then The deliverables here, as always, is the source code in plain text file. That means don't just give me a Word document. I need the text file, so the .r or the .py or the .ipynb, the Python notebook file. So whatever it is, we need that source code as well as any kind of write-up that you do. The rubric, similar to many of them, you want to shoot for the rightmost column. You want to use Python to read the GAFA data into a Python data frame. Append data from Apple, Facebook, Amazon to the data frame, and includes significantly more error checking logic to determine if the data was read incorrectly. And those are the ones that's the distinction between C to A, is that significantly more error checking logic. That means you probably want to take a look at some characteristics of the data, maybe also checking to see if there's any errors that occur and responding appropriately, and so on. Your next rubric there is, or next criteria, is to use a Python grouping function to group the data together for analysis, includes significantly more error checking logic to determine if the data was should be grouped correctly. And then use the R programming language to read into an R data frame, append data from Apple, Facebook, Amazon to the data frame, includes significantly more error checking logic to determine if it was read incorrectly, and then use R to calculate the mean standard deviation of each stock price, and then compute significantly more metrics for each stock price, such as min, max, median, and skew, or some other metrics. But you do want to go beyond just standard deviation and mean if you're looking for the mastery. And then R, the last one is use the R language to graph each of the stock prices using the default settings of a graphics library, and then the thing to get you to the next level up is include significantly more customizations of that graph by setting the various options to make it pretty. So that's essentially the ask for deliverable 5. And with that, I'll wrap this up. As always, if you have any questions, do let me know. That's what I'm here for. If there's a topic that you want me to talk about, let me know that as well. My plan is to talk about Module 6 on our next meeting on Thursday. And then at that point, we'll start circling around and hitting those topics that are of interest to you. So if there's something I've hinted at and haven't talked a lot about, let me know. I'm more than happy to help out. And as always, if you have questions about anything I've said, do let me know. That's what I'm here for. As always, stay safe, and we'll speak again on Thursday.